Hello, good morning, students. So, as you know, last class we discussed about different types of solar collectors, solar energy collectors. Okay, we found that solar energy collectors can be broadly classified into two types. One is called flat type collectors or non-concentrating type of collectors, and second category we called as concentrating types of collectors. Okay, so uh, today we will see mainly about the concentrating type of collectors, because previous class we studied about flat plate collectors. So they are examples for non-concentrating type of collectors. And in flat plate collectors, we have seen two varieties. One is liquid based, okay, water based or alcohol based, like that. And the second one was air based or gas based collectors. So they are the broad classification. So this time in this module we will purely focus on concentrating type of collectors. Okay, they have different varieties, and the topic itself is very interesting. And in focusing type, we will see that they can be broadly classified into point focusing type of collectors and line focusing type of collectors. So you may ask what is mean by point focusing and line focusing. So we will see very shortly what is point and what is line. Okay. So in point focusing type of collectors, usually light beam or radiation is brought to a single point. Okay, you will have a focal point. At that point, light will be collected using some lenses or some mirrors. Light will be focused to a single point. Whereas in case of a line focused collector, the light energy is not brought to a single point. Instead, line energy, solar light energy is brought along a line. Instead of a point, you will have a line. So we will see how this is done. So mainly in focusing type, what is done is shown here. It is focused to a small area by means of some focusing device. Okay. Even though we call it point focusing, but practically the light may not be focused a single point, it may be focused a small area. For example, in this dish antenna type of collectors, this you can see a parabolic. This is called parabolic reflector, in which light is reflected and brought to a small area. Okay, you can see the area of the reflector is very large, but area in which the energy is focused is small. Okay, the energy focused in the area of focusing, the temperature will be very high. Actually, in fact, the temperature will be very high. And how this is done? Okay, this is usually done by using lenses and mirrors. Okay, lenses and mirrors are used to focus the light to a small area. Okay, so we will see example for mirror type for collectors and lens type collectors. And in these collectors, radiation falling on a large area is focused in small area. That is what is done. Okay, so that is why it is called concentrating. The term meaning of concentrating is bringing to a small area. Okay, bringing together to small area. That is why we call it concentrating. And how this is operated in this place shown in the figure, there will be some chamber, some container. The container, some fluid will be filled, maybe some liquid, maybe some gas. The gas is heated to very high temperature, because temperature may go as high as say 500 degrees Celsius. So it is a very big temperature. Okay, you know, water is boiling at 100 degrees. Okay, so this is around 5 times more than that. So temperature attained is very high. So corresponding good effect we will get. We have already mentioned that there are point focusing and line focusing. In point focusing, what actually is happening is shown here in this diagram. Suppose this is a reflector. You have seen such reflectors in torchlight, okay, vehicle headlamps, you can see, okay, cycle headlamps, you can see such reflecting headlights. So their shape is actually called parabolic. Okay, the shape is called parabolic, and every parabola has a focal point. Understand? A focal point. So whenever light falls on this parabolic reflector, complete light will be focused to a single point. That point is called focal point of the parabola. Okay, even though this is a two-dimensional diagram, you can imagine a 3D diagram. Understand? Then also the light will be entirely focused to this point. Okay, it's called the focal point of a parabolic reflector. Same is happening in the case of a solar collectors, where at this point, at the focal point, what is done, a container will be kept and it will be filled with some liquid, some gas. So what happens? Gas or liquid will be completely, its temperature will be raised to a very high level. Okay. So see some points on point focusing type of collectors. Okay, they are essentially consist of some reflecting surfaces. That is what I show. Reflecting surface. It may be made up of glass or some metallic sheet. Highly reflecting metallic sheet will be used to construct this device. Okay, point focusing reflector. Okay, so that's the first thing. And another important thing is that they actively track the sun. Actively tracking sun means morning sun rises at the east and at evening sun sets in at the west. Okay, so naturally sun is continuously dynamic, it is moving. So in order to get maximum light, there's a dish or this reflector should also move accordingly. So in fact, this will be connected with a sensor, an electronic sensor. Electronic sensor will sense the position of the sun. Accordingly, using a externally driven motor, this dish is moved from morning to evening, so that it always get the maximum sunlight. Understand? Maximum sunlight. So it is a driven system using some remote control or some sensor. Otherwise, you may not get enough sunlight throughout the day. You may get sunlight at the noon, or you may get sunlight at the afternoon time. But if you want to get the exploit maximum solar energy, this should be rotated from morning to evening. I hope that is clear. And this can work as a single unit or as a multiple unit. Both are possible. You can install a single unit or multiple units. You can connect them together. You can connect them together. Then the efficiency of the device will be much higher. Okay, a ray diagram is given, a schematic diagram is given here. You can see here a small container is placed here. In the container, some fluid is there. That fluid is heated up. When it is heated up, when the solar radiation falls on that reflecting surface and get focused at the focal point, as I showed earlier. And once it's heated, it goes to high temperature, high pressure. So that vapor you can use to run some motor. Understand? So you can see some detailed things here. Such systems are called Stirling engine based solar collectors. Stirling engine based solar collector. This is the engine actually. Reflecting surfaces you can see here. They reflect the light. And here in fact in a Stirling engine is essentially gas is used. Some gas is used. And gas is heated up. The hot gas, which is a high pressure gas, the hot gas, high pressure gas is used to run some generator. Okay, you can run the generator just like the engine in a bus or a car. Okay, which is being heated, petrol or diesel is being heated, and it produces a high pressure gas. Similar here, fuel is not petrol or diesel, instead solar energy. Solar energy is made using heating up the gas inside the chamber, and the hot gas, its pressure is high, it has high ability to do work, and that high pressure gas is used to run some engine. Okay, so such reflectors or point focusing collectors are called Stirling engine based collectors. Okay? So it is written here, it consists of a parabolic dish composed of some reflecting material, usually some metallic surface. Glass is very rarely used. You are using some metallic plates. And heat from these collectors are generally used for operating Stirling engine. Yeah, that's the name of that engine. Okay, not in the name of the inventor scientist. Okay, and as I told you, these engines make use of the heat energy coming from the reflector, and a gas is heated. And the hot gas is used to drive a motor, and motor generate electricity, just like in an electric generator. Understand? So usually there may be large number of such units. Okay, a single units may not be enough to do any practical purpose. So we have a series of such engines, a series of system. The electricity produced by all systems are added up together and supplied for any day-to-day life application. Okay, you can install such systems nearby to a housing colony or any residential area. You can install, and electrical energy can be used for our day-to-day applications. So next, let's come to what is called a line focusing type of collectors. In line focusing, as I told you, what is happening? You have a trough like this, a semi-cylindrical surface. Inside of that is silvered or made very smooth. So they will be highly reflecting. And what happens? The reflected light will be focused along a focal line instead of a focal point. You have a focal line here. That's why we call it line focusing type of collectors. And along the line, what is done? You have kept a metal pipe, a hollow metal pipe is there. So, and through this hollow metal pipe, continuously some fluid is circulated. So what happens? The entire light energy or heat energy that is getting focused along the focal line is getting absorbed by the liquid. Okay, so the liquid is entered from one end and taken out from the other end. So continuously this liquid is circulated. So what happens? Temperature of the liquid rises up. Okay, so you have so many applications with hot liquid. You can use it to run an engine. You can use it to for a boiling purpose or cooking purpose or any industrial purpose. You have so many industrial applications of hot water. So many applications. Okay, so this is a single unit is shown here. In fact, its working is shown in this animations. Okay, let us see some important points. So here what is happening? Solar radiation after reflection of the surface is concentrated at the focus of the parabola. In fact, this is a parabolic shape. Okay, the surface is parabolic shape, and we know for a single parabola you have a single point. But this is a long cylindrical parabolic shape. So focal point will be line. Instead of a single point, you have a line, and the energy is focused along the line where we have kept your pipe. Okay, if the reflector is in the form of a trough with a parabolic cross section, this is called a parabolic cross section, then solar radiation is focused along a line. Okay, line should be underlined. Line. That is why it is called a line focusing. And the usual normal dimension of a trough type reflector is shown here. It may be of length which may vary from 3 to 5 meters and can have width ranging from 1.5 to 4 meters, like that. Okay, so it may vary according to the requirement. There is no hard and fast rule that this should be always like this, nothing like that. Okay. Anyway, a typical system will be of this much length and this much width, and so on. And yes, you can connect such systems. Okay, you can connect a large number of systems so that you can improve the efficiency of the system. Understand? So usually large number series of reflectors are connected. So then it will be much efficient. For examination purpose, a figure like this will be enough. Okay, don't attempt to do this kind of diagram. If any question is asked, you may use this kind of schematic diagram. For point focusing type, this will be enough, and for a line focusing type, this will be enough. Understand? So here everything is very clearly shown, how it is getting focused, what is kept along the focal line, and how fluid is circulating. Everything is clearly shown here. So these two diagrams are enough for point focusing and line focusing. Okay. Again, another important feature is that line focusing can again be classified into three different types. Okay, three different types line focusing, because they are of much higher importance than point focusing. One is called parabolic trough collectors. That's what we have seen just now. And second type is called mirror strip collectors, and we will see very shortly. And the third one is called Fresnel lens based collector. Fresnel lens based collector. Okay, so let's see one by one. Parabolic trough collector you have already seen. So that is what is shown here. Okay, you can see large array of parabolic reflectors. Okay, this is a real diagram, real photograph operating in nearby to many thermal power plants or solar based power plants. Okay, you can see human beings. Okay, small human beings here. This is a panoramic view from a faraway place. In fact, these structures are very giant in size. Okay, giant sized. Understand? So working principle is shown here. Even though the structure is very complicated and very vast, the working principle is shown here in the graphics. Okay. So that is what is happening in a parabolic trough collectors. And as we have already told it, okay, this type of collector brings the focused radiation onto a line, and their shape would be roughly of a semi-cylindrical shape, Even that is a over-exaggerated statement. You cannot say semi-cylindrical, partially cylindrical, you can say, a curved surface, but it is linear. Okay, linear. You cannot compare with a headlamp or a torch headlamp or something. No, because it is linear in shape. Observer is located at the line focus in a cavity. Okay, cavity means a hollow pipe is there. That is called cavity. And fluid flows in and out of the observer cavity through externally connected pipes. I already showed you. Okay, how liquid is entering into the pipe fixed on the focusing line, and how liquid is coming out. It's a continuous process. Throughout the day, it goes on happening, and this can be turned automatically. Okay, so that sun can be tracked in a line with the focus. Okay, this is actually not fixed. Okay, they are not rigidly fixed. They are connected to a motor. Motor is connected to a sensor. So what happens morning to evening? This entire array of solar collectors moves from east to west, so that it can collect maximum solar radiation. Understand? Both heat energy and light energy. Okay, such arrays are shown here. And let us go to the second category of line focusing collector. We call it as mirror strip type of collector. There is not much difference. Instead of a plate, you will have some strips. You can see in the diagram. Small metal strips are fixed here. Metal strips. So they will again act like a parabolic reflector. And at the focal line, you can see here the tube fixed here. Through the tube, liquid is running. Okay, this is a single system. I have shown is a single system. You can connect a series of the system to improve your performance. But here, instead of plate, you have strips. So strips have a lot of advantages. Mainly, they can be easily transported from one place to another. And secondly, they can be easily assembled. If you have a big, huge, large plate, its transportation is very difficult. Its fixing is very difficult. So many problems are there. But in comparison to that, if you are using strips, you can easily pack it up, you can easily transport, you can easily assemble it. Understand? So, in short, a mirror strip type of collector contains large number of metal strips pasted or fixed on a curved structure. Okay, you will have a metallic welding structure on which these strips are fixed. Focal point will be along a line. We already mentioned it. Okay, they are fixed in such a way that all of their focal point will be along a line. Here the white line is the focal line. Okay, light falling on every strip is getting focused to this pipe. And such surfaces can be easily mounted and deassembled. Okay, it is the one of the main advantage of mirror strip type of collectors compared to trough type of collectors. And yes, it is very easy to install at a place compared to trough type. That is advantage. So nowadays, because of this reason, mostly people prefer to have mirror strip type of collectors. Okay. And the third category of line focusing type is called Fresnel lens collectors. Fresnel lens collector. It is written as Fresnel, but pronounced as Fresnel. Understand? And the key difference of this device from other two is that it is based on lenses. Okay. Previous two devices were purely reflecting surfaces, but here it is lenses. You know about convex lens, concave lens, etc. Here we are using a plano convex lens. We have used a plano convex lens, and the curved surface is cut into grooves. Okay, these are specially made by experts, engineers. Okay, when a convex lens is grooved like this, some cuttings are involved here. The entire light will be focused to a small area. Okay, small. You can say a point or a line. Because it is a long strip, it's actually it looks like this. This is actually a Fresnel lens. Okay, it is unlike from ordinary lens. You see them in circular shape. Here it is not circular; it's a rectangular shape. But the upper surface, curved surface is grooved. Special cuttings are given. So that light gets focused on a straight line. Understand? Here it is lens. It is made up of glassy materials or some polycarbonate materials, very transparent. So light will get focused along a line. And next step is very simple. You know what is done along this line. A metallic pipe will be fixed there. Through the metallic pipe, you will pass some fluid. Maybe some water, maybe some alcohol-based fluids. Okay, they are mainly used. So automatically they will be boiled. Okay, so very interesting device. So the main points are here. It is a special type of lens with certain grooves on the curved surface. Grooves. These are called grooves. These cuttings are called grooves. So they are specially made technically. Okay, the technical details are not required for you. Due to the lensing action of the device, energy gets focused along a line. That is also clear. And secondly, it is highly fragile and hence must be handled carefully. That is one of the demerit of this device, because it is a glassy material. If it is not made up of polycarbonate, so it must be handled carefully, otherwise it may get broken. So during installation time, care has to be taken in dealing with such a device. Okay, compared to metallic strips, so they may be easily handled, but this kind of things cannot be easily handled. And because of this glassy nature, thick nature, they are heavy. They are comparatively heavy also. That is also another feature of Fresnel lens collector. So now, what we have covered two type of collectors. One is flat plate collectors or non-focusing type of collectors, and the focusing type of collectors known as concentrating collectors. From this study, I hope you understood that concentrating type of collectors are more beneficial or more useful because they are highly efficient compared to flat light collectors, because light can be focused to small area. so energy loss will be minimum. So they have some certain advantages. Let us see one by one what are the advantages. These are all important topic which may be asked in an examination. So first is installation intensity is higher, very high, because that means sunlight getting focused to small areas very high. Okay, so intensity is very high. In a flat plate we are not focusing, so intensity is very low. But here we are focusing the radiation to a small area, so you can say insolation intensity or solar radiation intensity is very high. Secondly, working fluid can attain higher temperatures because you are running some fluid through it. In flat plate collector also you circulate some liquid, but temperature attained is hardly 100, 150 like that. But here temperature can rise as high as 500 degrees Celsius. Understand? So you get much more efficiency. So we say that working fluid can attain higher temperature, so it can be easily evaporated. You can use it to rotate turbines. You can generate electricity. In the next module, we will study about once a device. Okay, device will be studied in the next unit, which is used to generate electricity from sunlight. You can generate electricity, and the energy loss per unit area is very small. Of course, because there is not enough surface to radiate, because energy is focused to small area, so energy loss will be obviously very small. And yes, the last one is very important advantages. A reflecting surface require less material compared to absorbing surface. Okay, in flat plate we had absorber, but in reflecting plate we don't have any thick absorber, and plate can be of thin type. So cost wise it is more beneficial. We need to spend a less amount of money to build up a concentrating type of collector. So less material required means correspondingly less expenses. So these are the four main advantages of concentrating type of collectors. Okay, so now this module's content is over. Now this is the time for an assignment. We have a question now. With the help of diagram, explain the working principle of line focusing solar energy collectors. Okay, you need to select only one. Okay, we explained the three types. You take any one of them, give a diagram and explain briefly its working principle. Okay, so this is a very interesting question. And secondly, what are the advantages of concentrating collectors over non-concentrating collectors? We have seen now, you can add even your own points. You can add additional points from your textbooks. So this is also an assignment question. Okay, so hope you understood it clearly. You are requested to watch the video at least twice before attempting any assignment. Try to understand the concept very clearly and try to speak yourself after watching the video. Try to speak yourself about the content matter and check that whether you are able to speak it clearly or not. Okay, so with these comments, let us sign off. Thank you for